Hi, I'm Hailey Gonzales, and this is Ecology, the study of the distribution and the abundance of organisms, their interactions with other organisms, and their interactions with their physical environment. Next is population ecology, which is the study of the growth and abundance and distribution of the population, and it can be dependent on the size of an actual population, the density, the dispersion, and the age structure. Age structure to the right can be described by this chart. As you could tell in this example, the lower age, the higher the percentage individual number there is, and as the age grows higher, the smaller population is there. And then for the survivorship curves, there's type 1, type 2, type 3. Less reproduction, higher mortality rate is type 1. Type 2, death age can happen at any time. And type 3, high reproduction and low survivorship is going to happen. To describe population growth, there is biotic potential and carrying capacity, which basically they're both the highest a population can reach. They are affected by limiting factors, which factors that prevent a population from reaching it. And there's density dependent and independent factors. Dependent is within a population, such as predation, like shark and flounder. Then there's density independent, which is something outside the population that affects the population from growing, which is in this case a shipwreck or a storm or a natural disaster. Next is community ecology, which is the interactions of different populations. One is interspecific competition, which is competition between different species, like competitive exclusion, resource partitioning, and realized niche. Realized niche is a job that an organism can find that it has to do. Next can be predation, which is like predator and prey. And then there's symbiosis, which are relationships between two different types of species, which is mutualism, where both species benefit, commensalism, while one benefits and the other has no effect, and then there's parasitism, where one organism benefits while the other is harmed. Next is the energy levels in ecosystems, which can be explained by a food chain or a food web, which is a more complex version of a food chain. They are basically transfers of energy between trophic levels. Trophic levels can start at the producer, which is most likely a plant. Then there's an herbivore, which is next eaten by the primary, secondary, and tertiary consumers, which then their dead bodies is basically eaten by decomposers. Next, we have the biogeochemical cycles, which is the flow of essential elements from the environment to living things and then back to the environment. In this case, we have the hydrological cycle, which is water, carbon, phosphorus, and nitrogen cycle, which is nitrogen. For example, down here we have the phosphorus-water cycles in effect. Biodiversity is the number of species, niches, and trophic levels in an ecosystem and the complexity of its food web, which is basically a good thing. It can be determined by its habitat size, climate, and latitude. And as for species diversity, there can be dominant species, keystone species, which play a vital role in an ecosystem, and invasive species, which species that don't belong in a certain ecosystem and are introduced by humans. Now on to human impact on ecosystems. Humans have a great role on ecosystems. They've contributed to global warming, ozone depletion, deforestation, desertification, acid rain, pollution, and the reduction of species.